Hi guys, welcome back to the channel, and in this video I will cover frequency distribution and then nature of those distribution. So I will cover bar chart, pie chart, and then skewness and kurtosis. So let's get started. So first of all I am importing Seaborn as SNS, then I am importing matplotlib.pyplot as PLT. After that I am loading the dataset tips from Seaborn library. The type of this df variable is Pandas data frame. I will run this cell. Now I will show you this dataset using df.head method. So this is the dataset. So in this line of code, I am finding all the unique items in the day column using .unique method. So this column has mainly 4 items: Sunday, Saturday, Thursday and Friday. Now using .value counts, I will show their frequencies. So these are the frequency of each day. After that I will plot the bar chart. For that I will select the column, then .value counts method, then I will apply .plot method, and the kind I will give will be bar. So this is the bar chart. On the x-axis we have the days, and on the y-axis we have the counts, or you can say frequency. We can also draw pie chart using .value counts, then .plot, and in the kind parameter you have to pass pi, and the autopacity will be 0.2f. So the autopacity 0.2f represent that we want to see 2 decimal places. So this is the share of each day in total count. Now I will show you frequency distribution for intervals. So this is the total bill column. I can divide the total bill columns into intervals. For that I will apply the .value counts, and in this I will pass bins equal to 5. So I will be creating 5 intervals. Then I will apply the plot method, and the kind will be bar edge. So I want horizontal bar graph. So on the y-axis we have the intervals, and on the x-axis we have the frequency. So before moving on to skewness, I will first explain you normal distribution. So this is a normal distribution. It is a continuous probability distribution in a bell-shaped curve. So in this, mean, median and mode is equal, and 68% of the data lies within the first standard deviation, and 95% of the data lies in the second standard deviation, and 99.7% data lies in the third standard deviation. So an example of normal distribution would be the height of a large population. So on the x-axis the height will be given, on the y-axis the frequency will be given. So it is seen that it always forms a bell-shaped curve. Now moving on to skewness. So skewness is a statistical measure of the asymmetry of the probability distribution of data set, and this is the formula for skewness. So there are 3 types of skewness. One is positive skewness, in which the mean is greater than median. And then there is a negative skewness, in which mean is less than median. And then there is zero skewness, in which mean, median and mode is equal. Now moving on to kurtosis. It provides info whether the data is more peaked or flat as compared to normal distribution. So this is the formula for it. And in this also there are 3 types. So first is leptokurtic distribution. It is sharply peaked and with less variability of data. Then there's mesokurtic distribution, which is basically normal distribution. And then there is platykurtic distribution, which has the flattest peak and highest dispersed data. Now moving back to the Jupyter notebook, I will find the skewness of total bill column. So it is 1.13. So what does that mean? So whenever the value is greater than 0, that means our data is positively skewed. So the data will look like this. In this, mean is greater than median. Now I will find the kurtosis. It is 1.21. So it is also greater than 0. That means the nature of the distribution is leptokurtic distribution. So whenever it is greater than 0, it is leptokurtic distribution. When it is equal to 0, it is mesokurtic distribution. And whenever it is less than 0, it is platykurtic distribution. So this is it guys. I hope you like this video on distribution. Please like, share and subscribe, and I will meet you in the next video.